Hello everyone and welcome back to the channel. In this video, we will analyze the malware artifacts used in the Kaseya Revil ransomware attack. Some of the concepts discussed in this video are a bit advanced for newcomers, for example, DLL sideloading and malware configuration extraction. I intend to create dedicated videos on these topics in the future. In this video, we start off with the analysis of the dropper. The dropper contains a Defender executable and a malicious DLL which is side-loaded by the Defender executable. We will then move on to extract the malicious DLL, and then from there we extract the Revil ransomware payload embedded in it. In the last part of this video, we will focus on the extraction of the Revil malware configuration from the Revil payload. I already have a script which I use for this configuration extraction, which depends upon the section names to identify the section which has the configuration. However, in this case, the PE sections are destroyed. Therefore, there is no way to identify the configuration section. I will show you a way on how I can brute force the extraction of the configuration based on some previously known details. So let's dive in. All right, so here I am in my virtual machine. I have this folder called Kaseya. In it, I have two folders, dropper and main payload, and I have this Python file. We will talk about the Python file later. We will now focus on the dropper. So let me drag and drop this dropper in PE Studio. So in PE Studio, we can see that this is a 32-bit executable. The next thing that is important for us to see is the resources section. In the resources section, we see that there are two resources called Modulus and Softus. And if we look at further details related to them, we can see that they both start with 4D5A, which is the PE header. Now let us open this dropper in Ghidra and see how it is using these resources. So let me create a new project. The project will be Kaseya. And let me import this file. I will wait for this file to be imported and analyzed, and I will then resume this video. All right, so I think the analysis is complete. Let me open up the entry function. In the entry function, we will focus on the decompilation. So initially, this code is usually the compiler setup. The main code starts from here. So get wide win main command line. And after that, this is the first function that is called function 004010F2. Let me open this function. And here we can see right off the bat that some actions are being taken on the resources themselves. So let us look at this with further detail. So firstly, we see that a resource is being found. Let me rename this to var underscore find underscore resource. The next thing is the same resource is being loaded here. So I can say that var underscore load underscore resource. After this, the same resource is being locked. So I can rename this as well. So var underscore lock underscore resource. We can see that this is a global variable. Press OK. After that, we see that the modulus resource is being loaded here and the softest resource is being loaded here. So I think these two are the specific variables. So I can rename this again to underscore softest. This will be var underscore lock underscore resource underscore modulus. All right, so let's see what happens after that. So the modulus resource is being extracted here and it is being sent to this function along with the name of some file which looks like a DLL. And if I go inside this function, let's see what is happening here. This function is basically allocating a string. It is creating a string called c:\windows and the param3, which is the name of the PE file being sent here. So we can rename this arg_pe_name. We can see that arg_pe_name is being concatenated to c:\windows, which means that the path would be c:\windows and then appended with whatever is the name of the file. So basically it's creating a path here and then it is basically extracting the resource which is being sent to it here, and it is basically creating a file out of it and writing the file there on this path. So this is fairly simple to understand, not very complicated. We will go back and we'll go back to this function and we can rename this function to mw_drop resource as file. All right. So now we can see that this resource, modulus resource, is being dropped as the DLL, which I discussed in the introduction, that the defender executable, which is msmpeng.exe, is side loading this malicious DLL mpsvc.dll. And then after that, we see a create process being called. Create process is taking the application name, which is being returned from here. So which is obviously this name of this executable, right? So we know that the modulus resource is the side loaded file that we need to extract and review. So let me extract that and we will open it up in Ghidra as well. So we will close this, save this. Let me go to PE Studio again. And here I will extract the modulus, and I can go to the Kaseya folder and say modulus dot dump and close this. I will add this same file into Ghidra as well, modulus.dump. And I will resume the video after the analysis is complete. All right, so the analysis is complete. Let us go to the exports. This is the function service CRT main, which is the main function that we will be analyzing. So in it, we can see that a thread is being created of this function. So let us open this function again. We go inside and let us first look over this function, and we can see that a couple of functions are being called here. And after that, we see create file mapping and map view of file. Then we have based on this destination, which is received from the map view of file, it is being used to create a mem copy, and this function is being called. Let's go inside this function and we can see that this destination is sort of being passed as a function, and in it we are passing the reference for the load library and get proc reference. So I have a fairly good understanding of what is happening here. Let's start with the first function and I'll walk you through it. So in this first function, we can see that there is a while loop here, which is doing a XOR with something. There is another while loop here, which is doing a XOR with something. All right. I think there is no need for us to fully analyze this. We can fairly easily presume what is happening here. I think this is decoding or decrypting the payload which is hidden inside the DLL. And I'm assuming that the payload which is hidden inside this DLL is the Revil payload itself. So we can go back with this assumption and we can look at the next function here. So in the next function here, we can see that some other functions are being called. So we can go over these functions quickly as well. This is something related to crypto, as we can see the name. This is retrieving some global variable. This is again related to some kind of crypto. And then we have some new variables being created and initialized on the heap. And this is again related to some crypto, right? Again, something similar. All right. So we don't need to go directly into this. I think we have an idea and we can work based on our assumptions. Let me analyze this last function before we go back again related to crypto, I think. So we can go back. Let's go back to the main function where we saw the create file mapping. We have this create file mapping happening here. And we have this map view of file happening here. So let's look at these functions in MSDN to get a basic understanding of what they do and how they are being used in this DLL. So create file mapping creates or opens a named or an unnamed file mapping object for a specific file. All right, so each file, this is the file which is being sent toward a handle to the file from which to create a file mapping object. So that is fine. I want to see what is the return parameter here. The return value, if the function succeeds, the return value is the handle to the newly created file mapping object. So that is fine. We understand that. All right. So this will have the handle of the newly created file mapping object. So I can rename this to var underscore handle underscore map file. And we can see that mapped file is being sent to map view of file. So let's now see what this function does. So map view of file maps a view of a file mapping into the address space of a calling process. All right. So that is fine. We provided a file mapping object, and what does it return? If the function succeeds, the return value is the starting address of the mapped view. All right. So this is interesting. So this means that if we look at the return value is usually present in the EX register. So if we look at this value returned in the EX, we should see the starting address of the mapped view. All right. So I think we have a fairly good understanding of what we need to do. We can open this DLL now in the debugger and we can resume our analysis there. So let me open x64dbg. In x64dbg, in order to analyze this file, we will have to enable a couple of settings. So the settings that we need to enable are DLL entry and thread entry. Save it. And in order to analyze a DLL, I think I have mentioned this before. that we need to open up run DLL32. So this is open, and after that we have to change the command line. So in the command line, we will have to enter the path of the DLL file. So the DLL file, and the next thing that we have to do is enter the name of the function. So we will go back, enter the name of the function, and we can restart our analysis. Let me make a copy of this command line so that I don't lose this as well. Restart. And we should look here after we press play a couple of times, we should see modulus.dump here. So play, play, and we can see now modulus.dump is here. If we play some more, we will be dropped into the thread. If we see here closely, get current thread and set thread priority. If we see here, get current thread and set thread priority. So we are inside this thread function. We need to look at map view of file. So let's go to map view of file, which is here. I can put a breakpoint here and press play. And let me go down one more. I have an address here. So let me follow this in dump too. All right. So we can keep on going down a bit. And we should see some data being loaded in this memory section. All right. So data has been loaded here. And this looks interesting. This looks like some code. If I look at it in this assembly, we can see that this is the start of a function, push EBP, move EBP, etc. Let me go to the memory map of this file, fix the view a bit, and I will right click and set a breakpoint of execution of this function. So in case the execution is passed to this function, the x64 dbg will break over there. So let's play again. And we can see automatically that we are dropped into the function itself. So now when we are dropped here, we can make certain assumptions about what will happen. We know that the Revil payload is hidden inside the code somewhere. And in order for the Revil code or the payload to be executed, the section will have to be marked as read write executable, which means that the virtual protect function will have to be called at one time or the other. So we can put a breakpoint on virtual protect. The breakpoint on virtual protect is there. We can play this and let's see what happens. We are dropped in virtual protect. All right. And if you look at the documentation of virtual protect, so we see that the first address is being passed on the stack, and this is the address of the starting page of the region whose access protection attributes are to be changed. All right. So this first thing is the return, and this is the address. So let's view this on the dump. I will view this in dump 3. All right. So here we are. Let me execute it till return. And then execute this till the user code. And now we see that this code has changed. I want to show you something interesting here. So let's keep this on the side. Let's minimize this. And let me keep this on the side somewhere. All right. And now we can see that this YY and at the rate and this details are there. Let me open up a hex editor and open up an executable. I will show you what is happening here. All right, so the HXT hex editor is installed. Let me create a shortcut on the desktop. All right, so let me open another executable here and we'll see something interesting. Let's go to our desktop, malware, go to the Kaseya, and I will open modulus.dump. Can you see this? YY here and MZ here, but the MZ is not there, but the YY is there. All right. And then if we start going down, we see PE here, and then we have two dots and then L. We go down, we see something similar here. L is there and Z is there, but the PE is not there. So actually what has happened is that this is a PE file hidden inside this section, but the header has been destroyed. So what we can do is that we can extract this code and then we can move on with our analysis. So I will go to follow it in memory map. I will save this dump memory to file. I will save this on the desktop here. And let me open this. Once we open this, we can go back and we can see what is actually the location of this. So 6FC. So 6FC. So we see this is the YY here. And how many dots do we need before the YY? We need, so we need 12. So let's see. So we need till here. So let me go ahead and delete the rest of this. All right. And now we have 12. Yeah, we have one more. It starts at 0C. And here it starts at 0C as well. 0CFF. 0CFF. So we're fine here. Instead of the 00 here, I will add 4D5A. And the next thing that we need to fix is this PE here before the L. So two dots before the L has to be a PE. And what is PE here? 50 and 45. So the L is here. And then two dots before. So 50 and 45. All right. So we have fixed the header here. Let me save this. And let me drop this inside PE Studio. And once we open this up in PE Studio, we can see that this is an executable as well. And there are some strings here, over here, and then we have some sections as well. The names of the sections have been destroyed, and I will show you how to extract the Revil ransomware configuration from these sections as well. So let's look at the indicators. We can see some more details here. Next up, I want to show you that this is in fact the Revil ransomware payload. So I will cut this and let me drop this in the Kaseya folder. Let me open this up in Ghidra as well. So file, import. Once the analysis is complete, I will resume the video. So if we look at the entry, we see these two functions here. And if we go into these two functions, we can see here that this D word is being called directly, which means that this is some dynamic API resolution, which should be happening here. And what we should see is a loop which is going over all these global variables. So let me go inside and we can see that, this is a do while loop. It is going up till 330 and all these values 412 590, it's starting from here and going up till 330 of this UR2. And if we go back, we should be able to see that this global variable is part of that array as well, which means that this is dynamic API resolution happening here. All right. And so let me close this. And now I will show you an actual Revil ransomware payload as well, which will confirm that this is what we've extracted from the side-loaded DLL is in fact the Revil ransomware payload. So I will close this, save it, and I will import a file. Go back one folder. I will go to the Revil folder here. And in this Revil folder, I have this bin file, which is an actual Revil ransomware payload. All right, we'll go here and we see exactly the same thing. There are two functions being called. We will go inside, we see this global variable being called as a function here. And we see that there is a loop here. There is a do while loop here. And all these dynamic API resolution is happening here. So now we are sure that the payload that we saw was in fact the Revil payload. And now I will show you how to extract the configuration from that Revil payload. So let me close this. We will go back. I have this Revil folder here. I will go to the code and I have this code here, which is used to extract the configuration from the payload. This code can be used to extract the configuration from an original Revil executable. So let me open this up in Visual Studio Code. In the meantime, let me close this. So if we look at the Revil executable, let me open the Revil executable as well in PE Studio. The Revil executable, the original Revil executable has a section which is not one of the normal sections. And this section, which is this one here, S7BZ, it contains the configuration of the Revil ransomware. These are all normal sections. This is something which should not be there. And this is actually the configuration. All right. So what is happening in this code here is that it starts from here. I load the Revil executable here, and I have this allowed section list. And what happens is that I go over all these sections, and if a section name is not in the allowed section list, that means that that section is actually the Revil ransomware configuration section. And after that, I use this code to extract the configuration from there. And I have a sample configuration here as well. If you look at this sample configuration, we know that the word PID is present in the configuration, and we can use this understanding of this configuration to basically brute force the configuration from the Revil payload, which does not have the sections named properly. So this is something which I have done here. But what I will do first is that in order to show you what I've done, I will do it again. So let me copy this, paste it here. I will copy this and paste it here and open this with Visual Studio Code as well. So in the extract config, I will put the name of this file. Extract config, I will put the name of this file here. And I will say dot slash. I will remove the names of the allowed sections, and I will remove this as well. And here we see that the data is being extracted. The section data is being extracted here. The key is being extracted, the CRC configuration length, etc., etc. And here is actually the configuration, the dump of the configuration. So what I can do here is that if dump dot decode Python string decode ASCII, ignore errors. So I think I can use this. So if dump.decode this, and I will say if pid in this, that means that the configuration that we have extracted contains the pid. That is an indication that this is the exact configuration that we need. So let's see what happens. I will put a debug here and start debugging. All right, so let me put a watch on this. Let me move this a bit here. So this does not contain any ASCII characters that we would be interested in. So we'll play again. This does not contain it as well. Play again. This one does not contain it as well. Play again. And we can see PK here, which means this is actually the configuration. So let's see what happens. All right, so I think the configuration has been dumped and we should see a file here, config decoded. So let me open up this file. We will change this file to a JSON file and I will format this file as well. So we can see that this is PK9 whatever and this here as well. So let me take this and Google this and we should see a link on GitHub where somebody has dumped the configuration that they have extracted or Revil ransomware. See, we have this. Revil config file. And if we do this, we can see that this is the same configuration which was dropped by FWSR as the revil.json, and this is exactly the same which we were able to extract from this. So I think this has been an interesting activity for us to understand how different payloads are embedded into DLLs, etc., and how a DLL can be side loaded as well. So I think that is the end of the video. Thank you very much for your time, and I hope to see you in the upcoming videos.